Okay, so back in chapter 1, we have talked about IPv4. The last thing was to mention about IPv4 is that IPv4 has two types, public IPv4 and private IPv4 version. So IP addresses has two types, public and private. The public were purchased for money, depends on the region that your company resides in, and it contains internet or it carries internet packets. The private was for free for some ranges, and it did not. It was only inside, or let's say it not common. It was local inside your organization. It's not allowed to go outside your company, outside the edge or the boundaries of your network, because to avoid entirely the entire the entire exhaustion of IP addresses from the beginning, from the first timings or era of the IPv4, back when it was developed and produced in the 1960s. They made public and private because that's for two things. First one, to avoid duplication. The other one was to avoid the complete exhaustion. So what do you mean by that? What I mean by that is that I mean that using an IP address of 10.10.10.10, how would you ever control or guarantee that this IP address is only used on a single computer in a single spot in this entire planet? It's impossible. Can you guarantee that? You cannot at all. Maybe there is 1,000 person at the same time using the same IP address, and if all these IP addresses were allowed to go outside to the internet, then we will have a cloud of the internet receiving 1,000 packet. All of them come from the source of 10.10.10.10. So what will happen to the internet? It will not be confused. It will be dropped down entirely. No internet at all in the world. So let's make it two types: private, that will never go out to the company, and public, that's only allowed to go around the world and carry internet. And private will give it some IP addresses, but it will not be allowed to be advertised. So you are not saying things that are matching. You are saying something, and just few seconds after that you are saying the opposite. What I mean is that, again, for the third time, is that you say that my computer, this one that I'm using in the office or in my home, in my house, it must have only a private IP address like 10.10.10.10, which is a private pool. Okay, and this one is the only one that I can assign to my device, and it cannot carry internet. So how will I have internet? How will I do that if public IP addresses cannot be assigned to local devices internally, and also they will be exhausted, so I must assign private addresses? All of this confusion on whatever happened in the network was shortened and solved by a network address, which is the IP, a network address translation. Here comes a protocol called NAT, that at the very edge of your network, which is a router, and I will just give you a golden tip in a few moments coming. There is a router that will receive all the private IP addresses of the network. All of them are requiring internet, and private IP addresses cannot go out to the internet. So what will this router do using NAT? It will translate the private IP addresses to public IP addresses and resend the same request of internet to the world sourced by the public IP addresses. And once the replies come back from the internet using the destination of the public IP addresses, this device, again, as it did it first, it will do it again, will take this public to translate it again back to the private IP addresses and give the reply back to the network inside the company. So this is the job of the NAT, that I will distribute, I will assign private IP addresses to all my network devices, and I will put the public IP addresses that my company bought for money, for charges, okay, inside one router at the edge of my network. No need for all the routers to know about it, just like DHCP, one router is enough. And anyone is running inside the network. Maybe my computer, all it's doing all the day is that it's talking with a server locally inside my network to import some documents and some data. It's communicating with other devices by sending email between them, and these devices, all of them are inside my network, or maybe sending local services, not just email, sharing just some local informations. And also it's connected to a printer, so I can print some documents or scan them, and that's it. All of these procedures and all of these criteria doesn't require or do not require internet. So my private IP address of 10.10.10.10 is more than enough for me. But just once I do require internet, just at that very time, and my devices want to go out to this world, my private address is not allowed to go out. Okay, so you can see now the difference that not all devices are allowed to go out. So some devices private IP addresses are more than enough for them, and this will avoid the exhaustion of the public IP addresses. But other devices that do require internet, I will also give them a private IP address, but I will store for them or reserve for them a public IP address and put it inside the NAT router. Once you wanted internet, go to the router. This router will translate your private IP address to a public one, send it to the world, and when the reply came back, it will retranslate it again from public to private and give you the result that you wanted from the internet. So this is the job of the NAT and all the flavors of the NAT. There are 3, 4, 5 flavors of the NAT that you will know in the CCNA, CCNP, and CCIE. All of them do the same concept, translating between a bunch or maybe a part or a type of IP address to another type of IP address. Okay, so all these are all the types. I'm sorry, this is the concept of NAT. You must know that there is something called NAT translating from private to public, private to public, public to private. There is something for private to private in other studies and other certificates. There is something called from IPv4 to IPv6 and vice versa. Okay, this is NAT 64. There is something from 1 to multiple and multiple to 1. This is NAPT or path that you will study in CCNP. Okay, so don't get confused. We will talk only about NAT in here and the methods and labs of NAT. So private IP addresses does not carry internet, then public IP addresses do, but they cannot be inside. So NAT will do translate private to public and vice versa. NAT, my dear, is done only, and one last third only by routers, no switches, no multi-layer switches. This is why there will always be routers in your network, and you will never get rid of routers and depend on multi-layer switches for layer 3 functions. There will always be routers in your network because switches and multi-layer switches cannot perform NAT. This is how they are made, designed, and produced. NAT is done only on routers. Okay, never forget about that. Never think that you can reach the internet by building a network entirely from switches and multi-layer switches. You need to buy an expensive router. Okay, so types of routers, the one we will study and the one we will not. Static router is that inside your NAT router you will tell it that when you receive something from 10.10.10.10, please translate it to become 5.5.5.5, which is public. When you receive something from 10.10.10.11, please translate it to 5.5.5.11, and this way. So one by one, this static method, because you manually inform the router that each private IP address should be translated to each one of these public IP addresses. Okay, this is annoying because you might have more than 100 devices in your network. So what you'll have a dynamic translating. Dynamic translating is that you will inform the router whenever you receive, check this one, whenever you receive an IP address from this network, translate it to whatever IP address from maybe this network, which is public. Okay, you can see the same subnet mask mean the same 254 available IP addresses. So I now have about 254 private IP addresses inside my network, so I will buy for charges 254 public IP addresses and put both of these pools inside my router and inform the router whenever you receive whatever IP address from these, just give it whatever public IP address from these and reserve it temporarily for it until it completes the function, and that's it. So this is much more simpler, just in case you have multiple devices. A third type, which is the genius type, okay, this did not solve everything because exhaustion is still there. What I mean is that building a company that have 1 million device or 1 million user requires 1 million private IP address and 1 million public IP address. So this will mean that IP addresses in the world, the two types, private and public, must be equal in the number of available addresses. If I have like 2 billion public IP address, then there must be 2 billion private IP address. You know, by default, the total number was about 4 billion and 294 million and such number after that. So maybe if we split it to half, it will be about 2 billion and a bit of 80, 98 or 95 million IP address private and the same number public. This one also does not support the growth of networks worldwide. So there comes something very genius, which is called NAT or PAT, which is port address translation. Okay, the PAT. What will PAT do is that it will do a one public IP address to 65,535. How's that done? I'm sorry, terribly sorry. Okay, this will be done by buying maybe 100.100.100.100 public IP address, and I have 10,000 private IP address in my network. So virtually it will do this: 100.100.100.100 colon 1. It will establish an extended port for this IP address, so it will be an IP with a port, okay, and port 2 and port 3 up to a virtual port 65,535 in this way. Can you imagine that? One IP address, public IP address I purchased for money that that will serve 65,535 private IP address. So this is very genius, which has three names actually in the exam. All of them you will face them in the CCNP, I believe, because it has been removed to implement in the CCNA, the new one. But just in case you face it, it's called PAT, NAT, or NAT overload. And in the command, when you configure PAT, you don't mention PAT or NAT, you just mention NAT overload, and the router will know that you mean to translate from 1 to 65,535. So this is the concept of NAT, and these are the three types of NAT. In the previous CCNA, again, it has been simplified now. You were asked to configure NAT, static NAT, dynamic NAT, and PAT. In the new CCNA, you are asked to configure static and dynamic NAT only, and for PAT it has been removed and escalated to the CCNP. So we will now configure in the upcoming video, in the upcoming lab, static NAT, after that dynamic NAT, which is done by using pools or groups. For PAT, it will be configured in the CCNP, just in case we have made a course for CCNP. And I believe we will. It will be a missing line. Okay, so thank you so far for watching. I hope the concept of NAT is clear and simple for you to know and understand. NAT is done only on routers. Don't forget that. Never forget that in your life. In the upcoming video, I will start the labs, which is first the static NAT, after that the dynamic NAT, and we will verify it and see the commands to verify and to implement. Okay, so thank you for watching, and we will see you in the upcoming video. Goodbye.